Hi guys, this is me Project Human. So today I'm gonna explain all problem from today's unofficial D4 round. So let's start. So in the first problem, it's called directional move. So in this problem, you're initially looking at east, okay, and you're given a string. If a string, the string contains only 0 and 1. If the character is 0, then you make a 90-degree turn to your right. If it's a 1, you make a 90-degree turn to your left. So that's basically it. Like you're gonna be facing east. So if you make a 90, if you're facing east, okay, and you make a 90-degree uh, left turn, then you get to north. And if you're facing north, if you make a 90-degree left turn again, you go to west. If you're facing west, you make a 90-degree left turn, you go to south. If you're at south, if you make a 90-degree left turn, you go to east. And it's just vice versa, other way around. Like if you make a 90-degree right turn from east, you go to south. So after iterating through the whole string, you just have to say now which direction you are looking at right now. It's just a simple if else statement problem, just a simple implementation. I hope there is nothing more to explain here. So let's now go to the second problem. So in this problem, you're given an array. So in this problem, you're given an n and in numbers of array. Okay. So suppose the numbers are 2, 1, 2, 4, and 6. You can choose any of the two numbers. Like you can choose 1 and 6. Okay. And replace 6 with like 6 with 1 plus 6 plus 1, or if you choose the other way around, you can also replace 1 with 6 plus 1. So the goal is to make the whole array odd. Okay, like suppose if this array was given, you have to make all of them odd by doing only these operations. So what we can do is, like you can choose, sorry, what you can, how do you choose that, I forgot. To indices I and j, replace ai with a. So you can choose 6 and 1 and replace 6 with 6 plus 1, which makes it 7, which is odd. Then you can do the same thing with 4, then same thing with 2, and they all are going to be odd after these operations. So here you need minimum of 3 operations because there are 3 even numbers in this array. Now when is that impossible? If there is no odd numbers in the array, like suppose 2, 4, 8 and 10. If it's like that, then you cannot make them odd, because even plus even is equal to even. You need odd number to make the array odd. So there has to be at least one odd number in that array. If there is not at least one odd number, you cannot make the array odd, and the minimum number of operations you need is the number of even numbers left. Like if there is no odd number in the array, then you cannot make the array odd. So you just have to print -1, and otherwise you just have to print how many even numbers are in the array, which is the minimum number of operations you need to make the whole array odd. So this is make all odd. So let's go to the next problem. The next problem is team. So in this problem, so in this problem you are given n members and their skill set. Like every number will represent a student's skill set. So you can make a team of at most 2 members. You can also make a team of just 1 member. Now you have to print maximum number of teams you can form that has a skill set combining. Like if you make a team of 2, they have to combine to k, or if you have a team of 1, his skill set has to be greater or equal to k. So how many maximum teams you can make? So suppose let us take the first case, so which is 5, 8, and it's 9, 9, 3, 4, 4, 5. Now what we can do is, the first thing that we can do is like sort the array. Let's just sort the array. Now 9 is already greater than 8, so we don't need to waste another member by combining it with 9. Okay, if we do that, we are wasting another member. 9 is already greater than 8, so we can just make a team with a single person of 9. Okay, so what we can do is we sort the array, and from the very last, the last one has the largest one, so from the very last we start iterating and see how many one person team we can make that has already has the skill set of k. Like suppose if there were 7, okay, not 5. Let me remove this. What if there was 8? Okay, and here was another 10, 12, and 13. They all have a skill set greater than 8, so they all can make a single person team. So I make 4 teams here, every team containing only one person. Then now 5 don't have a skill set of 8, so what do? I choose 5. Okay, then I iterate from the beginning, because if I pair 4 with 5, okay, then I am losing this 4 plus 4. This 4 plus 4 will be another 8, like 4 plus 3 will be 7. So I am losing a team here. So what I do is I take the largest one, then iterate from the very smallest one and see which give me the skill set equal to k. Like suppose there was 9. Suppose there was 9 and there was a 2. Okay, so it's a 2 here. Now I choose 5 here and iterate from here. Like 5 plus 2 gives me 7, so I cannot make a team with 5 and 2. Then I go to the next one. 5 plus 3 gives me 8, so I make a team of them. Now then I go to its left and 4. Now do I have to iterate from the very beginning again? No, we don't, cause if this one will be equal to or less than 5, because the array is sorted. Okay, so if this number cannot make a team with this number, this number certainly cannot make a team with this number. So what I do is, like, from iterating from the very beginning, I just start iterating from the last time I stopped. So it will be like 5 and 3 makes a team, then 4 and 4 makes a team. So this will give us the optimal answer. So what we do here, we sort the array, start from the very last and see how many 1% team we can make. Then we do a 2-pointer situation here. I iterate from last and start iterating from the first, like to choose the 2 partners, 2 eligible partners who has a combined skill set over or equal to k. So this will give me the optimal maximum team number. I hope you guys have understood this solution also. Let us go to the next one. So okay, XOR game. To be honest, for me this was the most exciting problem, I would say. So in this problem, you are given A and B. Okay, and you have to choose C and D. Now there is a condition. Okay, C has to be less than or equal to A. Okay, and greater than or equal to 1. Same for D. D has to be less than or equal to B, greater than or equal to 1. Now the thing is, the point of, suppose, whose point is whose point okay, so the point of Alice is A XOR B, and the point of Bob will be C XOR D. Now you have to make C XOR D strictly greater than A XOR B. If that happens, then you will print yes. If not, then you will print no. Like, what we can do here is we just have to convert A to his binary representation and B to his binary representation. So suppose I have A like this, okay, okay, and a B like this. Okay, now what will XOR give us? XOR gives if um, if two of them are the same, then it returns a false. If two of them are different, then it returns a true. So the XOR of AB will be, sorry, the XOR of AB will be something like this, right? Now we have to choose C and D less than or equal to A and B. Okay, now what if I just do one thing? Like, if there is a 1 and 1, what if I just change that one or this one to a 0? What does that make it? It makes this number, now this new number, okay, suppose this was the initial number. Now I change a 1 to a 0, so suppose this becomes this. So this number is clearly smaller than this number, and if we make a situation like 1 1 to a 1 0, then this 1 XOR with this 0 will become a 1. So this XOR is going to be strictly greater than the initial XOR. So what do we do here? Suppose if it was like this, okay, so there is actually no 1 1 situation here, right? So we, no matter what we do, we cannot choose C and D less than A and B and make their XOR greater than A XOR B, right? Because there is, like, if I add a 1 here, that means it is greater than A. Or if I add a 1 here, then that means it is also greater than B. I cannot choose greater than B or greater than A. So there is no way I can make the XOR of CD strictly greater than the XOR of AB. So here the answer will be no. But if there is a case like this, okay, what I can do is I can make this one a 0, and which is smaller than the initial B, so the XOR will change, and the XOR, like suppose if it is a 1, then the XOR was 1 0 0 1 0. Okay, it's a 1 here now. Now I change the 1 into a 0. Okay, I change the 1 into a 0. Okay, now the XOR becomes 1 0, so it's a 1 and 0, so it's a 1. So this is strictly greater than AB. Okay, so what do we do here? We just convert them into binary and see if that there is a 1 1 situation. Now there is a clever way of doing it. What we can do here, if we see one thing, like if there is no 1 1 situation, right? The XOR is the similar of A XOR B is the similar of saying A plus B if there is no 1 1 situation. So we just have to check if A XOR B is equal to A plus B, then it's a no, because there is no 1 1 situation. And if A XOR B is not equal to A plus B, then there is a 1 1 situation there where I can change any of the 1 into a 0. So the P C XOR D will be strictly greater than A XOR B, and the answer will be yes. So this is the solution of the problem D. Now the next two problems, these are two classic. It's a classic DP. So in this problem, you are given a string. Okay, like string S. Okay, the string can only contain digits and dashes. Like suppose, like let's take us the first test case like this. Okay, now I have to print how many ways I can make the string a non increasing non-increasing string. So suppose there will be no increasing part, so I cannot, sorry, there will be no decreasing part. No, I'm really sorry, pardon me, non-decreasing. The we have to print the string in non-decreasing order, so there will be no increasing part. Pardon me. Okay, I am kinda confused here. I'm confusing other people, I guess. I'm sorry for doing that. Okay, so there will be no, like there will be no situation where it gets 9 then 5 or 9 then 8. I'm sorry. So there will be no decreasing here, like there will be only increasing, non decreasing. Okay, so I have to print how many ways I can make the string non decreasing one. So this is a classic dynamic programming problem. So like suppose, okay, suppose dp index, okay, and digit. In this in this dp index digit, I will save the number of sequence that end at index with the digit. Okay, like suppose it was dp 3 with like digit 5. So that means I have to save the number of in sequences that end at non-decreasing sequences that end at index 3 with the digit 5. Okay, like the number, like suppose this is a sequence that at index 3, sorry, this is a sequence that at index 3 it ends with the digit 5. So I have saved here, I will save here the number of non-decreasing sequences that end at index 3 with the digit 5. Okay, now how do what is the transition point here? Like if a yeah, non-decreasing sequence ends at index 2 with the digit 1, that can also end at index 3 with the digit 5 because 1 is less than 5, right? Also, the sequences that ended at index 2 with the digit 2 can also end at index 3 with digit 5, right? Because 2 is also less than 5. So what we see something here, right? So dot 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 digit 2 5. So these 5 things, the all the sequences that end at the previous index with less or equal to the digit can also end at this index with the same digit. Like it will be non-decreasing because every all the other sequences had the last digit as a digit that is small or equal to the current digit. Okay, so we see like the transition will be dp index digit equal to dp index minus 1, and here it will be 1 2 up to that digit. The summation of all of them will say what is this number is. Okay, now we have two cases, like if this string I character is equal to a dash. Now what we can do is in this digit there can be 1 to 9, so that can be any variable from 1 to 9 there, and for every for every dp state we know how to calculate that dp state. Now if si is equal to something 1 or 9, then this in digit cannot this digit cannot be 1 to 9. It's already given, so the digit has to be what it is given. Like suppose like 1 dash dash 3, right? So at this position, okay, like I cannot say in this dp index digit, like it cannot end in 9 because it's already given it will end at 3. So I cannot choose here, like, but here I can choose. It can end at 1, it can end 2, because I can print anything here. Okay, like I can print 1, then 2, then 3, then 4, 5, 6, 7, 8, 9. But here I cannot print anything here because it's already given it's 3. Okay, so at the end my answer will be the last index and all the digit 1 to 9. The summation of this will give me the answer. Okay, this is a really classic dp. It's like there is a one transition, like the previous index with the smaller equal to digit number gets summed into the new index. And as for that, like you can solve it in iterative process, or you can also solve it in recursion. Like, do I show the code here? It's a bit tricky, I guess. So let me guys show you the code. Okay, so let me okay, so what are we doing here? It's like, okay, first of all, by the way, like we have to initialize the dp as 0, and all the 0, I just have to initialize dp01 as 1. Okay, because it's like if it's a dash. Okay, now I have to just one dash, nothing else. Okay, the answer will be 9 because I can do 1 2 3 4 5. If dp, okay, 0 1 was equal to 1, then what is the transition point here? Okay, like now here can be anything. So first I calculate for dp11, then I calculate it for dp12, and every one will give me a 1. So at the end of the day I'll have a 9. Okay, this means this will have dp 0 1, and this will have dp 0 1 plus dp 0 2. Now dp02 is 0, so dp01 is 1, so dp12 will also be 1. So that's why, like dp01, we just have to initialize it with 1. Then if it is between 1 and 9, what I do, I just from 1 to that digit, okay, I just add them up. I am using add because it's like I have to use mod. Like I have double done this mod. You don't have to do that. Like it is costing you. Like just you can just do a plus b mod, a plus, like I don't have to do that. It's like it's costing you way too much money, don't do that. That's bad. Okay, it's like I'm doing ad here. Now if else means it's a dash, then what I can do is I can use any digit from 1 less than 10 is up to 9. Then for 1 to that j, I just add them and get the TP state, and at the end of the day what I do is I sum the last. L is my n here, so what I do is I just go to the last index and sum all of them up and just print the answer. I hope you guys have understood the problem. I think this is more difficult than E, I guess. Like if you are not familiar with DP that much. Okay, now let's go to F. Okay, F is a classic two pointer method. It's like, so I would hope you have already kind of read this statement, because this statement is kind of tricky. Like if I have to explain the statement, it will take more time. So I hope you have already read this statement. So what you are given is 8 and 5, and you have to, like, okay, let me explain the statement. Like you can use 5. You have, like, suppose I have some money, like 5 amount of money, and I can buy a sub array. Okay, some sub array, and what is the largest possible amount of sub array I can buy with this 5 money. Now the trick here is, if I buy this sub array, okay, now if I buy 3 once, then I don't have to buy this 3 with 3 again. Like I can buy this 3, and if I buy this sub array, this 3 will be free for me. So again, if I buy this 2, the other 2s will be free for me, because I have already bought 2. So this sub array will cost me 5. Okay, so what is the cost of this sub array? This sub array will cost me 1 plus 3 plus 2. Okay, so this sub array will cost me 6, and the whole sub array will also cost me 6. Okay, the whole array will also cost me 6. So we can do it, like, let's just do a simulation here. We can do it with count array and a 2 pointer. Okay, we just have to solve it with 2 pointer method. So first, the suppose I and j both are here. Okay, then I start moving the j forward, so j is here now. Okay, j was first here. Now if I need to buy this, I need to spend, like suppose I have a variable name spend sp. Now for buying this, I have to plus or 1 in sp. Okay, now the current value of sp is 1. Now I iterate to the next one. Okay, and also I do is count 1 plus plus. Okay, now I iterate j to the next one, and here comes the 3. Now I see if count 3, if it's greater than 0. If it is greater than 0, so we have already taken it, we don't have to buy it again. But if it's not greater than 0, then we have to buy it now. So if I need to buy it, what I need to do is I have to plus this in my spend 3. Now my current spend becomes 4. Okay, my here my spend is 4. Okay, my current spend is 4. And what is the amount of what is the amount I have bought is 2. Okay, now I iterate j to the next one. Okay, now I see if this 2, the count 2 is greater than 0 or not. I see count 2 is not greater than 0, so I do a count 2 plus plus, and I have to buy this, so my spend becomes 6. Right, now if my spend becomes 6, I have to stop my j here because j has already cost 5. Okay, now if I buy the next one, like I cannot buy the next one because it's 6 and I don't have enough money. So what I do is I now start iterating my I. Okay, now my I is here and it goes to here, so I have left one. Okay, I have left this. Now what I do is I do count 1 minus minus and see if count 1 is 0 or not. If it's a 0, then I take its value out of spend. Okay, and in which it becomes 5 again. So if it's 5, then I can buy the items, so I don't have to iterate one I anymore. I can start iterating j again. Okay, so I start iterating j. My j goes to here. Now my I is here, so my spend here becomes 5, right, because I have taken out this one. Now I go to 2 here. Now I check count 2 is if it's greater than 0 or not. If it's greater than 0, so I have already taken 2, so I don't have to add it to my spend, so my spend will remain 5 here, right? Then I take my j to the next one. Okay, my now 3 count of 3 is also 1, right? Now also we have to see one thing, right? Like if I'm taking it, I have to do like check if it's greater than 0 and also plus it. Okay, now we have taken 2 2s, 2 3s, right? Okay, if I go to the next and go to the next 3 and see count 3 is greater than 0, so we don't have to buy it, so my spend variable still remains 5. Okay, with 5 I can buy all of them, right? So now my count 3 is 2, my count 2 is 2, my count 1 is 1 because I am now in this box. I have iterated 1 to the next one and did a count 1 minus minus, so my count 1 is already 0. Now my j goes to here. Okay, now I come to this one. Okay, now I check if count 1 is greater than 0 or not. What I see is count 1 is not greater than 0, then we have to spend 1 to buy this item. Now my value becomes 6. Now 6 is greater than 5, so we cannot take buy this item, so I stop my iteration of j here. and start my iteration of I. Okay, now I go here. Okay, now I do a count 3 minus minus. After doing a count 3 minus minus, I see if count 3 is 0 or not. If it's not a 0, I cannot take it out from spend. Like now my I is here. Okay, okay, my I is here. Okay, and my J is here. So what is the cost to buy all of this product? Okay, I need 6. I still need 6. Okay, because there is 2 2. I need 1 2 to buy these 2 2s, and 1 3 to buy this 1 3, and 1 1 to buy this 1 1. Okay, so my mm, my iteration goes to the next 2. As I have dismissed this 2, okay, this 2 has been dismissed. What I do is I do a count 2 minus minus. And what do I see? If count 2 is 0 or not? Has it already become 0 by doing a minus minus? No, I had 2 2's, now I have 1 2, and I still cannot take it out from spend, because if we see like I to J, what is the amount I have to pay here for to buy 2 3 and 1? I have to spend 6. Now like I it's still not into my budget, like which is 5. So I iterate I to the next one. Now I have deleted this 2, so I do a count 2 minus minus again. Now what I see is 2 is become 2 has become 0, so I take 2 out of my spend. Now my spend becomes 6 to 4. Now 4 is in my budget, and we can see that like if I buy these 2 items I need only 4. So now I don't need to iterate my I further again. I now start iterating my J, because in my budget now. Then I just took my J to here and see if count 3 is greater than 0 or not. I see count 3 is greater than 0, then I just take it, and its cost now it has had become 4, and it's also 4, because if we see that is to buy these 3 items I need 3 1 and 3. I need 4, because 1 for this one and 1 3 for these 3. Okay, so in this way, when my SP is inside my budget, I just take the max, like suppose I initialize max answer. Okay, initialize answer as something like 1, I'm sorry 0, and I take max of answer, comma, whenever my SP is inside my budget, I check the difference of I and J minus I plus 1, sorry, J minus I plus 1. So at the end of the whole 2-pointer thing, we will have the max amount of sub-array I can buy with spending my budget, and this answer we just have to print that. Okay, I suppose this is just a 2-pointer implementation you have to do. It's like you I and J starts from somewhere, you start iterating J, you do that until the amount you have to spend is into your budget. When it crosses your budget, you start iterating I and try and see when the amount goes into your budget. When the amount goes into your budget, you start iterating j again. So at the end of the day, when your the amount you have to spend is into your budget, okay, you just take the maximum and it will be your answer. So this was the if problem. Okay, my code is kind of like I messed it up quite a bit. Like editorial's code is way better than mine, so I see, if you want to see the code, you can check out editorial's if problem solution. So I guess this is the solution for all these problems. I hope you understood all this problem and had fun doing this contest. Have a nice day. Happy coding.